financial math. And what we're going to start off by doing is a little bit of revision of the things that you need to know from grade 11. And these things are important in sort of creating a basis for you for understanding grade 12 work, and also because they ask you grade 11 work in grade 12. Okay, so it's important that we need these things, and I will certainly point out the sorts of questions that do come up again in grade 12. So the first thing that we need to be aware of are different compounding periods when using the compound interest formula. Okay, so I'm talking specifically about compound interest here. And we know our compound interest formula, A equals P1 plus I to the power of N. Okay. You didn't do this in grade 11 at your school. Really, Coltham? That's very interesting. You should have, unless this was, I might have been trimmed from the curriculum with COVID or whatever, but you should have done financial maths in grade 11. Okay. All right, let's just talk about what these different things mean. Okay, so anybody who has done this before, what does the letter A represent? What variable? What does A represent? Oh, okay, Gugu. Rewriting maths this year and only learned financial maths in grade 12 last year. Okay, the final amount, absolutely Amatle. Somebody else, the final amount, absolutely. The accumulated amount, absolutely. So this is our final or end amount. What does the letter P represent? What does the letter P represent, Matrix? Okay, so our original, present, absolutely. They also refer to it as your principal amount. Okay, so in other words, what you had in the beginning, what you had originally. Okay, so originally, i.e. at the beginning. The letter I represents what, Matrix? That's easy. That's our interest rate, absolutely, as a percentage. Come on. Our interest rate. Okay, and remember that's always going to be given as a percentage, so we're going to be dividing that by 100 always, always, always. Okay, and now the letter N. What does the letter N represent? No, Lebogang, we're just talking about the compound interest formula and what it means. So Ayanda, number of years. Number of payments, says Amatle. Number of periods, says Nobusutsu. Period, says Daka. So the letter N, Luzuko, it depends which formula we are talking about. Okay, but the letter N actually does not represent the number of years, not in compound interest. It also doesn't represent the number of payments because there's not a regular payment being made like there is with future value and present value formula. The letter N represents how often the interest is compounded within the period. Okay, so it is the number of times, it is the number of times the interest is compounded. Okay, that is very, very important. Okay, N is the number of times the interest is compounded. So in other words, okay, we can change the compounding period. When we are in grade 9, Interest, of course, that's the first time we hear about compound interest. Interest is always compounded annually. So if an amount of money grows and interest is compounded annually, say for 5 years, then N will be equal to 5 because it's compounded once a year for 5 years. 1 times 5 is 5. But when we get into grade 11, things are not going to be compounded annually anymore. They're going to be compounded more frequently than that. So if it has been compounded annually, that means once per year. Okay, we would do that in grade 9 and grade 10. In grade 11, it can be compounded semi-annually, which is the same as half yearly. That means twice per year. So in other words, every 6 months. Or it can be compounded quarterly, which means it is compounded 4 times a year. In other words, every 3 months. Or it can be compounded monthly. That means 12 times a year, so every 1 month. And in some situations, it could even be compounded daily. So that is 365 times a year, obviously not including leap years where there is an extra day. Okay, so the compounding period can be changed so that it can be compounded more frequently than just once a year. Okay, so for example, if I say that the interest is compounded semi-annually and money is invested for 3 years, what would the value of N be? I'm going to say that again, right? If money has been invested for 3 years and it's compounded semi-annually, what would the value of N be in this case? There we go. You guys have got it. Okay, so not 6 years. It's been compounded 6 times in 3 years because it's twice a year. Okay, so hopefully by discussing that, you understand what we mean by different compounding periods. Okay, good. Well done. All right. The other thing that I want you to understand before we go on any further is what compound interest actually looks like if we draw it on a graph. Okay, it is an exponential function, essentially. Okay, so I'm going to write these things in for you again. All right, so when we are talking about exponential functions take the form y equals, and then there's normally a base b to the power of x. Sometimes we can have an exponential function that looks like this. We've seen this before, all of us that are in grade 12, AB to the power of X, right? So this is basically what A equals P 1 plus I to the power of N is. Okay, so the Y, our output on our graph, is like our A, our end amount. Okay, the initial amount, A, is like our P over here. And our base for our exponent, B, is actually this entire bracket, 1 plus I. Okay, and X, our exponent, is like our N. Okay, so compound interest is exponential. Look at the shape of the graph. Okay, you can see that that is an exponential function. So N over here, it could be number of years if it was compounded once a year. And here you've got essentially A of N, just like you would have Y. Okay, I hope that makes sense to everybody. Okay, let's go and have a quick look. We'll just have, we won't worry about the annually, or maybe I'll just do that really quickly. I just want to show you what happens to an amount of money, okay, when we change the interest rate. Okay, what do you think is going to happen if I compound something monthly as opposed to annually? What do you think is going to happen to the money if interest is compounded monthly instead of annually? what do you think would happen? Yeah, it would grow faster, wouldn't it? Okay, because the interest is being calculated and added back more frequently. The money is going to grow faster. Absolutely. So if we have a look at part A, we're just going to do this really quickly. A equals P would be 15,000. 1 plus our compound interest rate is 15%. So we would write that as 0.15. And if it's compounded annually, then it means it's being compounded once a year for 3 years. So this would be to the power of 3. Okay, what do we get as an answer there? What are you guys getting for A? You can pop it into the chat. Okay, the rest of you getting the same answer? Yep, absolutely. So good, well done. All right, so remember we're going to put in the rand sign. And we're going to end up with, as you guys have been telling me, 22,813 Rand and 13 cents if we round it correctly to 2 decimal places. Brilliant. Perfect. Okay. So now let's have a look what happens, all right, when, for part B, where it is compounded half yearly. So that means that it is compounded twice a year. This is what we do, right? We say 1 plus 0.15. Okay, now this we have to divide by the number of times that it is compounded by. Okay, because it's being compounded twice in a year. Then what we have to do, because it's 3 years, we have to say 3 times 2 as far as our N is concerned. Okay, so let's just talk a little bit about why this is happening. First of all, why did I multiply the 3 by the 2? Yes, that's right, Colson. Thank you for the answer. Why did I multiply the 3 by the 2? Ntokozo, go for it.
Hi, ma'am.
Hi, Ntokozo.
Because it is ma'am, can you please repeat the question?
Sure, I wanted to know, why did I multiply my 3 by 2 in the case of this particular question? In the one above,
Because
yes, you go for it.
okay, because it is it is compounded half yearly, which means in a year it's going to be compounded 2 times for 3
Excellent.
years.
Good. Beautiful. Beautiful intercausal. Okay, so I couldn't have said it better. So it's going to be compounded 2 times in a year for 3 years. So that's 6 times that it would be compounded in the period. Okay, Leanne, let's just double check on that. We'll see if everybody's got the same answer or if you got a different answer. Before we do that, can somebody explain to me, why did I divide the interest rate by 2? Why did I do that? What was the point of me doing this? Does anybody know? Okay, no one's going to ever ask you this question, but it's nice to understand. And to cause a go for it, why?
I think this is the compound the interest rate, right? So I
Correct.
think it stays the same I think at the beginning of the investment. So no times we're gonna compound the interest. The interest rate stays like it's the same at the beginning of the investment, I think.
Okay, thank you so much for your answer. You're on the right track. All right. So the idea is that you'd have to work out what the interest rate is for the first 6 months and for the second 6 months. That's why we would have to divide it by 2. All right. So it's like Amahle saying in the chat, you divide the interest by 2 because it happens twice a year. So it has to be spread over 6 months. That's exactly it. It's what the interest rate would be for the first 6 months and what it would be for the second 6 months. Okay, Gugu, let me just have a look at your question. Is it because the total? Yes, that's correct, Gugu. 100%. Okay, so the rule is whatever you divide I by, you're going to multiply N by. So in the case of half yearly, you are dividing I by 2 and you're multiplying N by 2. In the case of quarterly, you are dividing I by 4 and you're multiplying N by 4. In the case of monthly, you are dividing I by, what do you think? What do you think you're dividing I by in the case of monthly? That's it, beautiful, by 12. Well done, everybody. So that means that we have to multiply N by 12 as well. All right. And crazy as this seems, if we're talking about daily, we would have to divide I by 365, which means we would have to multiply N. Indeed, Mamelo. Okay, by 365. Okay, so that's the important thing when it comes to changing the compounding interest rate that I wanted to convey to you. Okay, what you divide I by, you've got to multiply N by. Now, I see somebody got a slightly different answer. I just want to double check. We shouldn't be 1 plus 0.15 over 2. And then here. Okay, no, I'm getting the same answer as was put in the chat. Bianca, I suppose it is. Then it would be 52, but I've never ever seen that. Never ever seen that being given or asked as a question. Okay, but I suppose it would be possible. Okay. All right. So now that means that it ended up being 23,149.52. So you can see when we change the compounding period, even though the initial amount of money that was invested was the same and the interest rate hasn't changed, we've got more out at the end because we compounded more frequently. Okay, so you would find with each subsequent, exactly, Amahle. So you should find with each subsequent answer here from A through to B, C, D, E, you would find that your final amount at the end would get bigger and bigger and bigger. Monthly is important. That often gets asked. So let's just, for the sake of it, let's just do that one and then we can move on. So D, okay, we would have A equals 15,000 Rand, 1 plus, and then we would take our 0.15 and we would divide it by 12. And then we've got 3 years, so we would say 3 times 12 like so. Okay, and that's how we change the compounding period. As a matter of interest, what are you guys getting as an answer here? Yeah, good. Well done, Lesego. Me too. Tato. Yes, Lebogang. That's it. Good, 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 good. Well done, everyone. Okay, so 23,459 Rand and 16 cents. Okay, excellent. Well done, everybody. So you can see the power of changing or compounding more frequently. Okay, you can see how this amount of money is growing faster in the same amount of time. Okay, so now that we've had a look at changing the compounding period, let's go and have a look at a timeline sort of question. Okay, so let's just read this carefully. There's a lot of information here. 100,000 Rand is invested for 5 years at an interest rate of 16% per annum compounded quarterly. Thereafter, the accumulated amount is reinvested for a further 6 years at an interest rate of 15% per annum compounded semi-annually. Calculate the value of the investment at the end of the 11-year period. Okay, so I'm going to show you the long way that we could do this question, and then I'm going to show you something else that's going to be much faster that you can use in the future. Okay, let's just deal with one thing at a time. Okay, so what's important to us here is the amount of money that was invested, how long it was invested for, the interest rate per annum, as well as how frequently it was compounded. So up to this point over here, all right, A equals, and I want somebody else to tell me what it is that I should write. I'm subbing into my compound interest formula. What should I write? Okay, so yes, and Jabula. Okay, and Ntokozo, you got your hand up again. Go for it, Ntokozo.
And then we're gonna write 100,000.
100,000, lovely. Keep going.
Then open bracket,
Mm-hmm.
1 plus 0,15.
16. 16.
Oh, 1/6 years.
It's okay. It's okay.
Over
Keep going.
4.
Lovely. Beautiful.
Over 4, and then closed bracket,
Good.
then 5 times 4.
Excellent. Okay. Well done, Ntokozo. That is perfect. And of course, we would put that into our calculator like we have been, and we'd work out what this accumulated amount is. All right, what are you guys getting? You can share in the chat with me. Okay, I agree. Chadwin and Ayanda. Oh, Teddy, you putting the final answer. Okay, Teddy. So you went straight to the yes, lovely. Good, Awami and Gugu. Very nice. Okay, so that gives us 219,000 Rand, 112 and 31 cents. Perfect. Now they tell us that this accumulated amount, this A value here, is reinvested for a further 6 years at an interest rate of 15% per annum, compounded now semi-annually. Now they want us to calculate the value of this new accumulated amount. So what am I going to do again? I want to calculate the accumulated amount. What am I going to use as my p-value? What's my p-value? Because remember, I'm taking my accumulated amount and I'm reinvesting it. So what's my p? That's it, Luzuko. Yes, my previous answer. So it's 219,112,31 is my new p. All right, then that's your P. Quite right, Bianca. It certainly is. The interest rate has changed to 15%. So that's 0.15. And if it is compounded semi-annually, what do I need to divide 0.15 by? If it's compounded semi-annually, I'm dividing by. Good, guys. Well done. Absolutely. I'm dividing by 2. Okay, so now I've got to remember, if I divide by 2, I've got to times n by 2 as well. Okay, so this money is going to be in here for 6 years. So this is going to be 6 times 2, like so. Okay, and then eventually I'm going to get to my answer. Okay, so Teddy, I think this is what you gave us in the very beginning. Thank you for being patient while we do this the long way. Let's see what you guys get as an answer as well. Please do share so Yolanda and I can see what you get. Oh, wow, 11 answers. Cool. 52187. Nice, everyone. Lovely. Okay, so now it's interesting. Some of us are getting 2-3. Some of us are getting 2-2. Leanne, I'm getting a very different answer to you, Leanne. I'm getting what everybody else is getting. Gugu, yes, all good. Nobasutu, beautiful. Okay, so I'm getting 521,877 rounded to 2 decimal places. That would be 23. Okay, good. Well done. All right. So now Teddy did it in a super fast way. All right. From the very beginning, Teddy put that in the chat and he said, this is the final answer. Teddy, do you want to tell us how you did this just a little bit differently so that you went straight to the final answer instead of doing 2 steps like we did? Are you happy to share that with us?
Ma'am, I did actually the step, but just faster.
Oh, okay.
Yeah.
All right, no problem, Teddy. That's fine. Okay, so Leanne, you just used the wrong interest rate. Not a problem. Okay, so what you can do is this. Check this out. Okay, so we're going to do what we did initially, which was the 100,000 Rand. 1 plus 0.16 over 4. 5 times 4. Now remember, this gives us our accumulated amount of 219,112,31. So what we can do is instead of working out the answer and then plugging it in again into compound interest, we can simply multiply that by our second bracket. Okay, but we are multiplying, not adding or subtracting. We are multiplying by our second bracket because the money is staying in the account and it is regrowing. Okay. All right. So that means you could put all of that onto your calculator in one step and you'd see we'd get this answer over here. Okay. So 521,877,23. Okay, absolutely, absolutely. But you know what? Sometimes we don't always have the time to do things a longer way. All right. I'm not saying that you have to do the short way. If the longer way makes more sense to you and you prefer that, that's absolutely fine. Okay, so remember, it's exactly the same thing. Okay. All right. So this over here is your 219,112,31, isn't it? Okay, it is your 219,112,31. Okay, so it's exactly the same thing if you just write it all out in one line and then just multiply it by that. Okay, because you're going to do it here anyway. Okay, all right, Gugu. Okay, it's just a little bit faster. That's all. Okay, everybody. Okay, so don't forget, take screenshots if you want to. And let's move on and go and have a look at another question. Okay, so what if they ask us something like this? Mark wants to save up for an overseas trip in 5 years' time. He needs to have saved 120,000 Rand. If he receives an interest rate of 8% per annum compounded monthly, how much money must he save now? So in other words, how much money does he need to invest now so that he has 120,000 Rand in 5 years' time to go on his trip? Okay, remember we are working with compound interest. So I'm going to put the formula here for you. A equals P 1 plus I to the power of N. And I want you guys, that's right, Teddy, perfect. So Teddy says A is 120,000. It certainly is, because that's what he wants in the end. There we go, Amahle. Are we calculating the value of P? Yes. What makes you think that, Amahle? What was the clue? What did you read that made you think, okay, we're not calculating A now, we're calculating P?
Well, uh, when they asked how much money should he save, and they already gave all the information regarding the value of A, the interest rate, and the amount compounded monthly.
Absolutely, absolutely. Perfect. I could not say it better, Martle. Beautiful answer. Thank you so much. Okay, now I just want to address something in the chat. Lesejo, we cannot use the future value formula in this situation. When we work with, and I am going to talk to you guys about future value and present value, that is part of this course, but there has to be a regular installment. If you want to use future value or present value formula, there has to be a value for X. Okay, here he's only making one deposit in the beginning, and that money is staying in the account and it's earning interest over 5 years' time. And at the end, he wants 120,000 Rand. So it's not future value because there is not a regular payment. Okay, so for those of you that have done financial maths at school already, you can only use future value or present value formulae when there is a regular payment. It's usually monthly. It's usually monthly, but it could be quarterly, it could be half yearly, etc., etc. But there is a regular payment taking place throughout the period. Okay, Leanne's already given us a number, an answer. Okay, Leanne, let's see if what we get is the same as you. So our interest rate is 8%. So be careful here, that 0,08. It's compounded monthly, so it must be divided by 12. And here we would have to say 12 times 5. Okay, so I see there's another answer in the chat. Let's see. Tuelo, I hope I pronounced your name correctly. So you're saying the same as Leanne. Lozuko got the same thing, and so did Ayanda. Very nice. Okay, so to make P the subject of the formula, guys, you would have divided the 120 by the bracket. Okay, so the 120,000 has been divided by your bracket. I'm just going to quickly write that here. Well done. Okay, so P is you get error. Okay, Yamkela, are you remembering to close your bracket? Sometimes if you open a bracket, you must close a bracket. Your calculator is fussy about that. Tsidiso, we're going to speak about that now. Okay, so he's got to save, or he's got to put in 80,545 Rand and 25 cents now if he wants 120,000 Rand in 5 years' time. Okay, so Sediso is asking, why is it 12 times 5? Is there somebody else that can answer this question? Ah, you see, you forgot to put in the brackets. Okay, Yamkela, that's a very good lesson for you to learn. If you're working with financial maths, or it doesn't matter with you, it's just financial maths, but financial maths is where it happens more frequently. Make sure if you open a bracket, close the bracket. Okay, calculator doesn't like it if you don't, and then you get errors and you don't know what you've actually done wrong. Okay, Bianca, can you answer Tsidiso's question? Go for it.
The reason why we said 12 times 5 is because the trip is in 5 years' time. So we use the 5 in 5 years' time times the compounded monthly. Yeah.
Good, good. Well done. That's perfect. Okay, because it was compounded monthly or 12 times a year for 5 years. That's why it has to be 12 times 5. Well done. That's perfect. Thank you so much. Okay, Tiri, so you see now. Okay, cool. Good answer, Bianca. Thank you. Cool. All right. Nice, guys. How are we feeling? Are we feeling good? Are we managing? Thumbs up, thumbs down. We all okay? Good. All right. Good, good, good. I'm so glad to hear that. That's fantastic. Okay, so now things start to get a little bit more difficult. All right. So this is the hard part with financial maths, is that there's always so much reading. Okay, and then we have to pick out the information that's important and then decide what formula we're going to go and sub it into. But let's break it down for ourselves. Okay, so here we've got Jennifer. Jennifer is very lucky. She's got a boyfriend who gives her 4,000 Rand and she deposits the money into a savings account. 3 years later, she received another gift of 5,000 Rand from her boyfriend and deposited the money into the savings account. Jennifer's very lucky her boyfriend's giving her so much money. But anyway, calculate how much money Jennifer will have saved 3 years after her deposit of 5,000 Rand. Assume that the interest rate for the first 2 years is 18% per annum and that it changes to 18% per annum compounded half yearly for the remaining 4 years. Wow, what a lot of information. Okay. First of all, what we can do to help us is we can draw something called a timeline. Okay. What we first need to know is that from the beginning to the very end, how many years went by? Okay. So can anybody tell me from the very beginning to the very end, how many years have gone past? Okay, Mamelo says 7. Ah, Kumo. I hope I pronounced that correctly. You say 6. Yes. Seriso says 6 and Tokozo says 5. Good. Yes. 6 years. 6 years. Good. It's 6 years for a couple of reasons. First of all, they're nice and they tell us that the interest rate for the first 2 years of saving is this, and that it changes to something else for the remaining 4 years. Okay, so 2 plus 4 is 6. The other thing is that they tell us is that she receives 4,000 Rand immediately. 3 years later, she gets 5,000. And now they ask us to calculate how much money Jennifer will have saved 3 years after that. Okay, so the 3 plus 3 gives us 6 as well. So there are 6 years. So we can write it out like this: T0, T1, T2, T3, T4, T5, and T6. When money goes into the account, we make it a plus. So lucky Jennifer at T0 at the beginning, originally, she gets 4,000 Rand from her boyfriend. 3 years later, 1, 2, 3 years later, she receives another 5,000 Rand from her boyfriend. Okay. They want us to work out what she has at the end here at T6 for the first 2 years. So from T0 to T2, the first 2 years, 1, 2 years, the interest rate is 18% compounded monthly. Then it changes, and for the remainder of the period of time that it's in there, the remaining 4 years, 6 minus 2 is 4 years, it's going to be 18% compounded half yearly. Okay, does that make sense to everybody? Does this timeline make sense? Any questions before I start making the equations? Okay, what do you want me to repeat, Gugu? The whole timeline. Okay. All right. So the first thing that we need to do is we need to work out how many years the money has been saved for. Okay, so when we read it, we see that Jennifer gets a gift immediately of 4,000 Rand. All right. She deposits the money into her savings account. And 3 years later, she gets another 5,000 Rand from her boyfriend. So the 4,000 Rand has been in an account for 3 years when she gets another 5,000 Rand. It asks us to calculate how much money Jennifer will have saved 3 years after the deposit of 5,000 Rand. So in other words, 4,000 Rand goes into the account, it stays there for 3 years. 5,000 Rand gets added to it, and that money stays there for another 3 years. So 3 plus 3 is 6. That's not where we're going to start, Bianca. Okay, we've got to start with our initial deposit of 4,000 Rand. Okay, then they tell us that the interest rate is 18% compounded monthly for the first 2 years. That's the light blue. And the purple is the interest rate that changes to 18% per annum compounded half yearly for the remaining 4 years. So this is what needs to happen. Okay, let me explain it all to you because it's going to be a little bit long, but it's not difficult. Okay, we are using compound interest. Okay, 4,000 Rand goes in the beginning, and it grows at an interest rate of 18% per annum compounded monthly. That interest rate is only for the first 2 years. Okay. So here we would say 12 times 2. But the money stays in the account. She doesn't take it out. She leaves it there. She leaves it there. So I'm going to do for the next year from T2 to T3 with the interest rate changes, I am going to change that by multiplying by a new bracket because this amount of money stays in the account and now it gains interest. For 1 year, at that interest rate. Actually, sorry, it's not going to be for 1 year. It's going to be for 4 years. Sorry. After 6 years. Okay, Nhlanhla, we can check your answer. Okay, so this 4,000 Rand goes in. It earns interest at 18% per annum, compounded monthly for the first 2 years. The interest of the money stays in the account, okay, for another 4 years, and it earns interest at 18%. Oh, hang on. I made a mistake here. Sorry, that was supposed to be a 2. Sorry, guys. Sorry. This was supposed to be 2. It changes to that. And now it's going to be in the account for 4 years. Plus, we have a deposit at T3. So we are going to deal with that by adding the 5,000 Rand together with its interest. Okay, so this 5,000 Rand is in the account for 1, 2, 3 years. So this is going to be 1 plus 0,18 over 2. And here it is going to be for 4 years, that it's, sorry, for 3 years, 1, 2, 3 years, compounded twice a year. Okay. So Kumo, that's a very common mistake. Okay, remember the money is staying in the account from the beginning to the end. Okay, that initial 4,000 Rand, okay, does not start earning interest at a different rate when the 5,000 Rand is added to it. Okay, it still continues to earn the same interest that it was earning at the start of T2 or the end of T2 rather. Okay, Amahle?
Ma'am, when doing this question, for
Mhm.
those of us who prefer not to do it the shorter way, is it possible for us to say to say 4,000 bracket 1 plus 0 comma 18 over 12 and then 12 to the power of 12 times 2, and then you get that answer separately and you use the value for P, you use the answer that you get for the first calculation, and you use that answer as your value for P to work out that 1 year gap between T2 and T3.
Okay, well, you see, you don't need to do that. You don't need to work out the gap between T2 and T3 because the money isn't just in there for 1 year. It's going to be in there for another 4 years. Okay, so what you could do is take the dark blue part and work out the answer and then multiply it by the green. And then take that answer and then add the blue part at the end if you wanted to. Okay, you can do it like that if you like.
Okay, thank you, ma'am.
All right, does that make sense to you?
Yes, that does. Thank you.
Okay, all right, cool, no problem. Okay, so the 4,000 Rand that was initially deposited stays in the account from beginning to end. Okay, so that's why, but the interest rate changes. Okay, the interest rate changes after 2 years. Okay, so Kumo, you are saying you don't understand the green bit. Okay, so Kumo, that's because the interest rate changed. Okay, so it's exactly the same as what I was doing over here. Okay, in the black on this side over here. The interest rate, the money stayed in the account. Okay, but the interest rate changed. That's why I multiplied by a new bracket. Does that make sense, Kumo? Okay. All right. So, and Nhlanhla, I know you sent me something, but this is correct. Oh, hang on, where were we? There we go, with Jennifer. Okay. So now all that remains is for us to put this into our calculators and go and work it out. Oh, excuse me. Sorry, I'm just still putting this into my calculator. Okay, let's see what you guys are getting. We're all getting the same answer. Yes. Okay, so remember we need to round it off to 2 decimal places. So the 996 at the end is going to push it up. That means that we're going to end up, or Jennifer is going to end up with 19,779 Rand. Like so. Okay, lucky Jennifer. Okay, all right. So, are there any questions? That's it, Ntokozo, about this particular question. Anything that you want me to go back or re-explain or discuss with you? No. Ayanda, that's good. Alicia, well done. Are we sure there are no other questions? Okay, Yamkela. Yeah, the timeline really helps, Lorraine. It doesn't. It doesn't. The timeline does not count for marks. You don't get any marks for it, unfortunately. But it really, really, really helps you to draw the timeline. So throughout financial maths, I'm going to be drawing timelines with you. Sure, Palesa, there you go. Let me just go up and then you can screenshot the question. Let's just go over a little bit. And Japulo, you got a different answer. In Jabulo, sometimes what happens is that like we push a 3 instead of a 2, or we push a 4 instead of a 5. Just check, pleasure. Just check what you've got on your calculator. Okay, and Nhlanhla to the power of 8 in the green part. That's fine, not a problem. Okay, let's go back and go and have a look at this again. Okay. So the reason why it is to the power of 8 is because we are talking in Nhlanhla about how many times it's going to be compounded from T2 through to T6. Remember, it's being compounded 2 times a year for 4 years. That's why we've got 2 times 4. It will be compounded 8 times during that period. Okay, in the first 2 years, it was compounded every single month. Okay, so that meant that it was compounded 24 times in the first 2 years, once a month for 2 years. Okay. All right. Any other questions? Zuko, don't worry about questions like that. They're not going to do stuff like that with you with leap years and that kind of thing. They won't do that. Okay, but then it would be 366 in that leap year. It would be very difficult. So don't worry about that. They're not going to do that to you. I've never ever seen a question asked. No, you could write it, Tato. If you want to write it as 18%, you can. That's okay. That's not a problem. That's okay, Nhlanhla. Yeah, it's difficult, Gugu. It is difficult. Okay, your financial maths section, thank goodness, is not a huge part of paper 1. Okay, so we're talking about 15 marks out of 150. And the first few bits and pieces that we are doing on this course are really going to help you with the basic understanding of how financial maths work. Okay. Do I have any more examples? Yes. Here you go. This is a question that I was going to do with you. Here, try this one, guys. So I know Yolanda's put up the poll, which you guys must answer. Try this.